In this video, we want to calculate the average rate of change for the intervals specified. So first, we need to remember that the average rate of change is really just the slope. So we're looking at a curve, and this particular curve here is not a line. It happens to be a parabola. So essentially, we're looking for the slope from x equals 1 to x equals 7. So if you were to create a line from x equals 1 to x equals 7, the slope of that line is the average rate of change. So remember, slope is essentially the change in y divided by the change in x. So we want to subtract our y values, subtract our x values, and then divide the difference. So we have x values of x equals 1. So we're going to go ahead and substitute 1 into our function so we can get the corresponding y value. So that's 1 squared plus 7 times 1. 1 plus 7 is 8. So that means our coordinate is 1, 8. When we put in 1, our output is 8. Then we're going to substitute in 7. 7 squared plus 7 times 7. That will be 49 plus 49, which is 98. So when x equals 7, our output is 98. So now that we have our two coordinates, we're just going to subtract the y values, subtract the x values, and divide. So that's going to be 98 minus 8. That's the difference in my y values divided by the difference in my x values. So that will give us 90 divided by 6, which simplifies to be 15. So that is my average rate of change from 1 till 7. Now a quick note about slope. Let me just mention, for the computation that I just did, I started with 98 as my y value, but of course we could also compute slope starting with the 8. Let me just show you that. That would be 8 minus 98 divided by 1 minus 7. So in that case, we'd have negative 90 divided by negative 6, but you still get an answer of 15. Now, it's always a good idea to kind of have a graphical idea of what's happening. So let's make a graphical connection. Remember, as I look at my function here, f of x equals x squared plus 7x, I know that is a parabola. And I happen to know it's a parabola that opens up. I've done some thinking about this, and I know that my x-intercepts are at negative 7 and 0. Don't worry if you don't know that right now or off the top of your head, but I just want you to have a visualization here of what we have just found. So imagine if this is my parabola, and then if we were going from x equals 1, so that would be like, let's say this coordinate there, to x equals 7. I'm not doing this to scale, obviously. So let's say we have another coordinate there where x equals 7. Then basically, if we had connected these two dots with a straight line, that line, which is called a secant line, the slope of that secant line is what we just found, and the slope is 15, which makes sense because this is a pretty steep line and it has a very positive slope. So now let's move on to our second example. A new function with a new interval. F of x equals x squared minus 2x from 1 to 3. So again, let's go ahead and substitute in our x values so that we can get our y value, the output. 1 squared minus 2 times 1 is negative 1. So my coordinate is 1, negative 1. Substituting in 3 gives me 3 squared minus 2 times 3, which is 9 minus 6, which is 3. So that corresponds to the coordinate 3, 3. So now we'll compute our slope, which will be 3 minus negative 1. So again, that was my y value of 3 minus the other y value, which is negative 1, divided by 3 minus 1, which was the corresponding, the corresponding x value, there it is, 3 minus 1. So now let's simplify. 3 minus negative 1 is really 3 plus 1, which will be 4 divided by 2, which gives me a final answer of 2. And again, the graphical meaning of what we just found, this is actually the slope of the secant line from x equals 1 to x equals 3. That's my average rate of change from 1 to 3.